Ohm's law shows a linear relationship between the voltage and the current in an electrical circuit. With the water flow analogy, we can imagine the electrical current as the water current through a pipe. The resistor is the thin pipe that limits the water flow. The voltage is the height difference of the water that enables the water flow. Let's have a look at the Ohm's law formula. The resistor's current I in ampere is equal to the resistor's voltage V in volts divided by the resistance R in ohms. V is the voltage drop of resistor measured in volts. I is the electrical current flowing through the resistor measured in ampere. R is the resistance of the resistor measured in ohms. The Ohm's law formula can show that if we increase the voltage, the current will increase. If we increase the resistance, the current will reduce. Most circuits have more than one component called a resistor that limits the flow of charge in the circuit. A measure of this limit on the charge flow is called resistance. The simplest combination of resistors are the series and parallel connection. The total resistance of a combination of resistors depends on both their individual values and how they are connected. Resistors are in series whenever the flow of charge or the current must flow through components sequentially. This picture shows resistors in series connected to a voltage source. The total resistance in the circuit is equal to the sum of individual resistance. Since the current has to pass through each resistor in sequence through the circuit. According to the Ohm's law, the voltage drop V across the resistor when a current flows through it is calculated by using the equation V equal to IR. So the voltage drop across R1 is V1 equal to IR1. Across R2 is V2 equal to IR2. And across R3 is V3 equal to IR3. If we substitute the values of individual voltages, we get V equal to IR1 plus IR2 and plus IR3, or V equal to R1 plus R2 plus R3 in bracket. This implies that the total resistance in the series is equal to the sum of the individual resistance. Therefore, every circuit with n number of resistors connected in the series would be Rn series equal to R1 plus R2 plus R3 plus R4 plus Rn. Since all the current must pass through each resistor, it experiences the resistance of each, and resistance in the series simply add up. Individual resistors in series do not get the total source voltage but divide it. Ohm's law and parallel resistors. Each resistor in the circuit has the full voltage. According to Ohm's law, the currents flowing through the individual resistors are I1 equal to V over R1, I2 is equal to V over R2, and I3 is equal to V over R3. Conservation of charge implies that the total current is the sum of these currents. Here in this picture, 3 resistors connected in parallel to a battery. Here I equal to I1 plus I2 plus I3. Substituting the expression of individual currents gives I equal to V over R1 plus V over R2 and V over R3, or I equal to V 1 over R1 plus 1 over R2 and 1 over R3 into bracket. This implies that the total resistance in a parallel circuit is equal to the sum of the inverse of each individual resistance. This relationship results in a total resistance that is less than the smallest of the individual resistance. When resistors are connected in parallel, more current flows from the source than would flow for any of them individually. So the total resistance is lower. So the summary is, for series, the same current flows through each resistor in series. Individual resistors in series do not get the total source voltage but divide it. The total resistance in a series circuit is equal to the sum of individual resistance. Rn equal to R1 plus R2 plus R3 plus Rn. Summary for resistors in parallel. The total resistance in a parallel circuit is less than the smallest of the individual resistance. Each resistor in parallel has the same voltage of source applied to it. Voltage is constant in parallel circuit. Parallel resistors don't each get the total current, they divide it. Current is dependent on the value of each resistor and the number of total resistors in the circuit. So batteries have three parts: an anode and a cathode and an electrolyte. The cathode and anode, the positive and the negative sides at either end of the traditional battery, are hooked up onto an electrical circuit. The chemical reaction in the battery causes a buildup of electrons at the anode, that means the negative side. This results in electrical difference between the anode and the cathode. The electrons want to rearrange themselves to get rid of this difference, but they do this in a certain way. Electrons repel each other and try to go to the place with fewer electrons, so that place is the cathode. In a battery, the only place to go to is the cathode. But the electrolyte keeps the electrons from going straight from the anode to cathode within the battery. When the circuit is closed, that means a wire connects the cathode and anode, the electrons will be able to get to the cathode. In this picture, the electrons go through the wire. So in order to make the current flow, the battery has to be connected from the positive side with a wire to its negative sides. So when there's a voltage difference between the positive and the negative, then the current would flow through. So this is how the battery works. So what if you connect two batteries with their positive to positive charge? So in this case, the both batteries are in same volt. So they don't have really a volt difference between them. So because of that, the current wouldn't flow through. And what if we connect the negative terminal of the one battery to the negative terminal of the other battery? The same thing happens. So there won't be any voltage difference. If current has to flow, there should be a voltage difference. So the current flows from high voltage to the low voltage. Here there is no voltage difference, so therefore the current wouldn't flow through. What if we connect three batteries in such a way that their positives are connected together and their negative terminals are connected together? So the same scenario. So in this scenario, all the batteries are having the same voltage. So they push the current at the same rate, but their path is connected to a one single point. After this point, there are no path actually. So there is no circuit here. It is not a circuit. It's actually an incomplete circuit. And also there is no voltage difference. Therefore, the current won't flow through. So therefore the ammeter reads 0. So this is the answer.